All right, let's look at number 23. For 23, we've got the sign of the arc cosine of negative 3/5. So start on the inside. Let's come over here and look at arc cosine negative 3/5. So when we have an inverse trig function, that literally means we're playing Jeopardy. So here's the answer, and we're looking for the question. And remember, with inverse cosine, it's only valid in the first and the second quadrants. We get all of that from the definition of inverse cosine. Because this was negative, we have to be in the second quadrant because it's positive in the first quadrant. So if cosine is negative 3/5, I'm going to build a triangle. So cosine is adjacent over hypotenuse, and I can do Pythagorean theorem to get the other side, or I can recognize that this is a 3, 4, 5 triangle. We've already established this is in the second quadrant, so in the second quadrant we know that y is positive, so that would make this a positive 4. So from this inside piece, we have to get two things. We have to get the quadrant, and we have to get the values of the triangle. So we know we're in the second quadrant. We've got the values of the triangle. So now we want to know what is the sign based on that triangle. So I can look at the triangle and say sine is opposite over hypotenuse. So sine would be positive 4/5. And again, we're in the second quadrant. We know sine is positive there. All right, for 24, they gave us our triangle and they asked us how we could find angle A. So we know when you draw our triangle, we're going to use capital letters for the angles and lowercase letters for the sides. And remember that the side has to be directly opposite of the angle with the same letter when you draw that. All right, so we know that side A is 12, side B is 5, and we're looking for a way to express angle A. If the only two things that we know are opposite of that angle and adjacent to that angle, opposite over adjacent is tangent. So we can say the tangent of angle A is opposite 12 over adjacent 5. So to get A, we're back to playing Jeopardy again, right? We know the answer. We're looking for the question, so that means we would use inverse. So we'll say the inverse tangent of 12/5, the inverse tangent of the answer will give us our question. All right, then for 25, we just need to do Pythagorean theorem here to find the value that we need. So we know that A is 12 and B is 5, so we can do Pythagorean theorem and figure out that our hypotenuse C is going to be 13. And because it's a hypotenuse, remember that it's always, the hypotenuse and the radius are always positive. All right, then for 26, we said that we're 30 yards away from the goalpost, and it says that the kicker kicks at an angle of elevation of 30 degrees with the ground. And so we want to know how high off the ground the ball is going to be when it gets to the goalpost. So we're looking for this vertical height right here. So if I know this angle, I'm looking for what's opposite, and I know the adjacent. Opposite and adjacent is tangent. So I can say tangent of 30 is equal to the opposite, the height, over the adjacent 30. All right, so now to get h by itself, just multiply both sides by 30, and we'll have 30 tangent 30. Now, you can just throw this in your calculator in degree mode, or you can look at your unit circle and see that tangent 30 is square root of 3 over 3 and use that value. So 10 square roots of 3, if you put that in your calculator, that's the same thing as 17.3. So either one of those is fine. All right, then 27, we start working with simplifying using our trig identities. And the steps that we used were step number 1, look for a trig function squared. I don't have anything squared, so no Pythagoreans. Step number 2, we said look to see if we had any fractions we could combine or break apart. No fractions. Step number 3, can I factor? Well, there's no common factor here that I could take out. And so last thing we said was switch everything to terms of sine and cosine. So cosecant by definition is 1 over sine, and tangent in terms of sine and cosine is sine over cosine. So you can see our sines would drop out, and that would leave us with 1 over cosine, and 1 over cosine is secant. All right, for 28, again, go back to the beginning. Step number 1, look to see if we have any Pythagoreans, and we spot those with trig functions squared. So yeah, I have a cosine squared. So the Pythagorean that has cosine squared in it is sine squared plus cosine squared is equal to 1. So to get cosine by itself, I would just subtract sine squared from both sides. So cosine squared is equal to 1 minus sine squared. So I'll replace cosine squared with 1 minus sine squared. Now when I look at this, it's like, man, there's got to be some way like these 1s and the sines could cancel. I can't cancel things that are being added and subtracted. So instead, I'm going to need to see if I can factor this. So 1 minus sine squared, if you need to replace the sign and make it like an x and have like 1 minus x squared to be able to see, that's a difference of squares. 1 minus x squared would factor to be 1 minus x1 plus x. So 1 minus sine squared is going to factor to be 1 minus sine 1 plus sine. So then our 1 minus signs would cancel, and that would leave us with 1 plus sine. For number 29, again, I'm going to start off with looking for a trig function squared. Don't have any of those. Then step number 2, do I have any fractions I can combine or break apart? No. Step number 3, could I factor anything? I don't have any kind of common factor I could take out here. So last resort, switch everything to terms of sine and cosine. So sine's already there. Cotangent is cosine over sine, and then cosine's already there. So if I simplify these two things that are being multiplied right here, cosine times cosine is cosine squared. Now I have fractions. That was one of the things we said to look for. See if you have fractions you could combine or break apart with a common denominator. So I have 1 and sine, so a common denominator for 1 and sine would just be sine. So I'm going to multiply the bottom by sine to get my common denominator. What I do to the bottom, I also do to the top. So in my numerator, sine times sine gave me sine squared, and in my denominator, sine times 1 gave me sine. Now, why do we get a common denominator? So that we can combine, right? So let's take these two pieces right here and let's combine that over our common denominator. So now I'm going to go back to my list of things to look for. So step number 1, look for Pythagorean identities, and we can spot those if we have a trig function squared. And so sure enough, sine squared plus cosine squared is one of our Pythagoreans. It's just 1. So that gives me 1 over sine, and 1 over sine is cosecant. All right, then 30, they asked me to solve, and they give me tangent x is equal to the square root of 3. So all I need to do is look on my unit circle and see where is tangent equal to a positive square root of 3. So that's going to be right here at pi over 3, and then right here at 4 pi over 3. So that's where we got those two answers. For 31, just like up here, tangent was alone on one side by itself. I need to do the same thing. I need to get sine alone on one side by itself. So let's subtract the 1 from both sides, and then we can, to get sine by itself, divide both sides by 2. So we're looking for where sine is equal to a negative 1/2. So again, come over here to our unit circle, and we can see that sine is negative 1/2 right here at 7 pi over 6, and then right here at 11 pi over 6. All right, for 32, again, I need to get tangent by itself. So the first thing I'm going to do is divide both sides by 2. And now I have tangent squared, so I have to get rid of that square. I'm going to take the square root of both sides. Don't forget, when you put in a square root, you always put in a plus or minus. So now I'm going to go look on my unit circle to see where tangent is equal to either a positive 1 or a negative 1. And so if you look on your circle, that's at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Then for 33, there's no way to get cosine by itself because I have a cosine squared and a cosine to the first. So what we've been doing is replacing the trig function with a variable, maybe to make it a little bit easier to see. So if I replace cosine with just an x, that'd be 2x squared minus x minus 1. 2x squared minus x minus 1. So again, you can see there'd be no way to get x by itself. I would need to factor that. So if I factor, I'm going to get 2x plus 1 times x minus 1. If you need to use the SAT/ACT program on your calculator to help you factor, feel free to do that. And so remember, we had just put x in the place of cosine, so this would be 2 cosine plus 1 and cosine minus 1. So 2 cosine plus 1 and cosine minus 1. So now I'm going to set each of those factors equal to 0. So over here, I'll subtract 1 from both sides and then divide by 2. And I get cosine equals negative 1/2. Over here, add 1 to both sides, and I'll get cosine equals 1. So if you look on your circle to see where cosine equals negative 1/2, that's going to be at 2 pi over 3 and at 4 pi over 3. So again, you can see it right here, 2 pi over 3 and at 4 pi over 3. And then if we want to see where cosine is equal to a positive 1, that's only at 0. So those would be our 3 solutions. All right, for 34. They gave us the sine addition formula. So this is sine, cosine, plus cosine, sine. If we match that up with our sine addition formula from the sum and difference formulas on your formula sheet, this is what we get. So you can see that we're putting 100 where A is and 40 where B is. So then come over here and let's put 100 where A is and 40 where B is, and that would give me the sine of 140. If when I got here I had something I could simplify down further, like, you know, maybe sine 30, then I would go ahead and do that, but we don't know the sine of 140. All right, 35 and 36, they tell us that sine u is equal to 4/5, and u is between 0 and pi over 2. That means it's in the first quadrant. And cosine v is negative 5/13, and v is between pi over 2 and pi, so that means it's in the second quadrant. And they asked me to find cosine u plus v. Well, if you look at your sum and different formulas on your formula sheet, cosine u plus v is cosine u cosine v minus sine u sine v. They gave me sine u, but I'm going to have to find cosine u. And they gave me cosine v, but I'm going to have to find sine v. All right, so let's start with, since I know that sine u is 4/5, and I know it's in the first quadrant, then I'm going to draw a triangle and say sine is opposite over hypotenuse. And then I can use Pythagorean theorem to get this other side, or I can recognize the 3, 4, 5 triangle. Since it's in the first quadrant, I know it's going to be a positive 3. All right, so if this is triangle U and I want to know the cosine of angle U, cosine is going to be adjacent over hypotenuse, so that would be the positive 3 over 5. So cosine U is 3/5. Then the other thing we need is sine V. All right, so they told me that cosine V was negative 5/13, and we figured out it was in the second quadrant. So let's draw a second quadrant triangle with angle V. And we know that cosine is adjacent over hypotenuse, so negative 5/13. We could do Pythagorean theorem to figure out the other side, and we'll get plus or minus 12. Since this is in the second quadrant, we know that our y value is positive there, so we're going to use a positive 12 there. So to find our sine, sine would be opposite positive 12 over hypotenuse 13, so sine v is going to be 12/13. So now I have all 4 values that I need. I can just plug them into my formula. So cosine u is 3/5. Cosine v was given negative 5/13. And then sine u was given as 4/5. And sine v we found to be 12/13. So then we can just go through and multiply. 3 times negative 5 is negative 15. 5 times 13 is 65. And then 4 times 12 is 48. 5 times 13 is 65. Negative 48 and negative 15 gave us the negative 63/65. Then they also asked us to find sine 2u. So again, on your formula sheet, the double angle formula for sine 2u is 2 sine u cosine u. So we can just come up here and see sine u is 4/5 and cosine u is 3/5. So let's put in 4/5 for sine u, 3/5 for cosine u. And so 2 times 4 is 8, times 3 is 24, and 5 times 5 is 25. All right, then for 37, they ask us to find the cosine of 15 degrees using our half angle formula. All right, so half angle formula means that I need to rewrite 15 as something cut in half. So 30 cut in half is 15. So here's my half angle formula off of my formula sheet. I'm going to put 30 in the place of u. So if I come over here and put 30 in the place of u, I can find cosine 30 is square root of 3/2 off of my unit circle. To combine these, I need a common denominator. So I'm going to rewrite 1 as 2/2. So now I have a common denominator. So that'd be 2 plus the square root of 3 all over 2. 2 plus the square root of 3 all over 2 divided by that 2 right there. When you have fractions, remember that you're going to keep, change, flip. And so I end up with 2 plus the square root of 3 in the top and 2 times 2 square root of 4 in the bottom. Square root of 4 is just 2. I can leave my numerator alone. But I do have to figure out whether this is positive or negative. It's not going to be both. And so because I was finding the cosine of 15 and that's in the first quadrant, then we know everything in the first quadrant is positive. So that's why we choose the positive sign here.